I was asked in a comment to talk briefly about my 555 strobe circuit for the Voyager model. If you haven't used it already, this is 123D, which is made by Autodesk. It's a free online circuit building tool, and I'm just going to show you through what I did and how the Voyager circuit works. I just want to clarify at the start of this video that I am by no means an expert in physics or electronics, so if I say things that aren't quite technically right, well, live with it. So, typically speaking, when you build the 555 timer, it's made up out of a few basic components: 2 resistors, 1 polarized capacitor, 1 ceramic capacitor, and of course the 555 chip itself. That's all you need, and obviously power coming in and out, but we assume you have that anyway. I'm not going to go into detail about how the actual 555 timer works, but all you really need to know is how to wire it up. This is the circuit diagram. I know it might look a bit crazy, but it's just laid out like this so that it's slightly easier to read than normal. All of the ports here are numbered, which on the 555, your pin 1 is marked by the dot. Your typical use case of the 555 is to have a light turn on for a long period and then turn off. Naturally, because it's a strobe, we want it to do the opposite. We want it to be off for a long time and then turn on. We'll talk about how you calculate the specifics of that in a moment, but essentially, using the 555 timer in a strobe, rather than sending power through the chip, we're actually going to be sending the ground through the chip. To determine the timings of the strobe, you can just use one of these calculators. This is the one I use, the Ohms Law calculator at ohmslawcalculator.com. And you simply input the details you want, and then it'll tell you exactly what you're going to get. In my case, my primary capacitor is 47 UFs, so that's the same there. And my 2 resistors, my primary resistor is 39 kiloohms, and my secondary is 3.3. We simply put the details in here, and as you can see, it tells us everything we need to know about it. The period, which is the time for it to go on and off and then reset the loop, how long it's on, how long it's off, or in the case of our strobe, how long it's on and how long it's off, as we are inverting the way that the chip works. It'll be on for 107 milliseconds, and it'll be off for 1.378 seconds. And to get your ideal values, you can just play around with this to your heart's content. Just by playing with the numbers, you'll see how it increases and decreases as you change the various capacitance and other values. Coming back to the breadboard and the circuit diagram, if you want to see how I mounted the 555 timer on my tiny little piece of circuit board, you can check out the appropriate Voyager video. But I'm going to lay it out here so it's a touch clearer what's going on. The first thing we want to do is bring some power on to pin 4. And then that power needs to be jumped across to pin 8. Next, we need to join pin 2 and pin 6. Next up, we take our ceramic capacitor and plug it into pin 5, which we take straight back to ground. The next step is to position our resistors. The large resistor, in this case the 39K one, needs to go first. Notice that I'm placing this outside of any of these pins. And the smaller needs to go in the second position. Beneath both of these, we need to have our large polarized capacitor, which goes at the end of the chain. Make sure that your capacitor is polarized the correct way around. The negative terminal of the polarized capacitor can go straight back to ground. Next up, we can take pin 7 directly between our 2 resistors. We then bring our main voltage to the top of the resistor circuit, and we take another cable from pin 6 to between the second resistor and our capacitor. Finally, pin 1 we can take straight back to ground. Now, in order to see this doing anything, let's take this LED, drop it on this side of the board and just spin it around. And I'll just go ahead and plug that in, thank you. Go ahead, plug our negative terminal in. And coming out of pin 3, which is our output, we're going to go ahead and plug that into the positive of the LED. Check the polarity of your LED to make sure it's the right way around. And for the purposes of this demonstration, I'm just going to put this resistor in line so that you can actually see it working. Of course, our LEDs are all 12 volts or have a resistor in line. If I press the Start Simulation button, you'll see that the LED is on and flickers off. And of course, it only flickers off because it's only off for that 100 millisecond tiny little jot of time. And as you can see, this is the opposite effect of what we want to achieve. Now you ask yourself, how do we make this now work as a strobe rather than as an on with a brief off? This is very simple. We just invert the circuit. Turn off the simulation, flip our LED around, pop it in here, and rather than bringing power in as a negative, we're going to bring the power in as a positive. So now if I run the circuit, the LED is off and very briefly on. And that is exactly as simple as it is to create a strobe circuit with a 555 timer. You simply turn what is normally used as an output into an input that connects the circuit. If you need more insight into 555 timers beyond what I've presented here, there are plenty of good resources you can find on the internet. Just look for a 555 astable circuit. But for now, I'm Raven, and that's all from the lair.